Hello, assalamu alaikum. How are you doing, guys? Well, after talking about bases and the dimension of a vector space, now it is time to talk about another interesting thing, which is change of bases and the coordinate vectors. Well, you know, when we have a vector space V of finite dimension, then you can have a basis B, and let's say here B is U1, U2, Un. Now, for each vector you take in this vector space, your vector can be written as a linear combination of those vectors in the bases. So here, you can say U can be written as C1, U1 plus C2, U2 plus Cn, Un. Now, those constants, C1, C2, Cn, those they form what we call the coordinate vector of U with respect to B. So here, when you solve this system, well, here you get a system. When you solve that and you find C1, C2, those are called, as you know, those are called the coordinate vectors, the coordinate vector of U with respect to B. So this is called the coordinate vector, the coordinate vector of U with respect to the basis B. Okay? So here is the question. We can have more than one basis for the vector space. For example, I can take this basis here, U1, U2, Un, and then someone else can come and take this basis, B prime, U1 prime, U2 prime, up to Un prime. Of course, this is a finite dimension, so if this is dimension n, in both of them we need to have the same number of vectors. Okay, so here we have a basis, here we have a basis. Okay, now this vector U in my vector space, it has a coordinate vector with respect to B. Let's say here C1, C2, Cn. And the same vector, we can write it as a linear combination of this other basis. So basically here you have another coordinate vector with respect to B prime. Let's call this C1, C2, C1 prime, C2 prime, Cn prime. Okay? Again, those C1, C2, they are coming from the linear combination of those vectors. And the Ci primes here, they are coming from the linear combination of those vectors in these spaces. So the question that we want to address today is, what is the relationship between this coordinate vector and this coordinate vector? So here, what is the relationship? What is the relationship between U here, B, and U, B prime? That is the question that I want to address today. Well, it turns out that the relationship between them is a matrix. We call it the transition matrix. So here, U, B is a matrix multiplied by U, B prime. This matrix called, where B is called the transition matrix. The transition matrix. We write it B from B prime to B. All right, let's see why it is a matrix, and what can we say, or how can you find this transition matrix? Okay, so instead of taking this in general, well, I'm going to take here a vector space of dimension 2, and I clarify this. How do we get it? and in general, it will be the same idea. So if we take higher dimension, it will be the same idea. So the question is how to get it for dimension 2. Let's see. Let us focus. Let us focus on dimension 2. So in this case, we have B, U1, U2. And we have here B prime, U1 prime, U2 prime. Okay? Now, a vector U can be written as a linear combination C1 U1 plus C2 U2. And the coordinate vector U with respect to B is C1 C2. Here, again, U can be written as C1 prime U1 prime plus C2 prime U2 prime. And the coordinate vector of U with respect to B prime is C1 prime C2 prime. Okay? All right. Now, I'm going to take those vectors in these spaces. Of course, they are in my vector space. So here, those belong to my vector space. So I can write those as a linear combination of those vectors in my other bases. Correct? So here, because U1 prime is in my vector space, I can write it as U1 prime equals C1. All right, let me use here different constants. So let me say A U1 plus B U2. So I can write U1 prime as a linear combination of those two vectors in my first basis. And similarly here, I can write U2 prime equals ABC plus D U2. Now, let me come here and substitute in this. So what are we going to get? We are going to get U is C1 prime multiplied by A U1 plus B U2 plus C2 prime multiplied by CU1 plus DU2. And rearrange the terms, you get C1 prime A plus C2 prime C multiplied by U1 plus C1 prime B plus C2 prime D multiplied by U2. So this is U. All right, now let's write the coordinate vector of U from here. So it's going to be this and this. So here, let me keep this for a while here. And now we get the coordinate vector of U with respect to B is going to be C1 prime A plus C2 prime C, and here C1 prime B plus C2 prime D. However, I already know that the coordinate vector of U with respect to B is C1, C2 from here. So this means C1, C2 is this. Now, what is this? This, in fact, you can write it as the product of this matrix by this vector. C1 prime, C2 prime, this is A, this is C, this is B, this is D. Correct? That is exactly what we are looking for. So here we have this is U with respect to basis B. This here is U with respect to basis B prime. Here it is. C1 prime, C2 prime. And now this is the matrix that we are looking for. It is the transition matrix that will take you from P prime to P. That is the transition matrix that we are looking for here. Well, let's focus on this transition matrix that we got. What is this transition matrix? You can see from here, the first column. What is the first column here? AB. AB, here it is. AB is the coordinate vector of U1 prime when you use the first basis. So this is, in fact, U1 prime when you write it with respect to B. And the second column, this is, in fact, U2 prime when you write it with respect to B. C, D. That is the coordinate vector of U2 prime when you write it with respect to this basis. So now we understand what is the structure of this matrix. The structure of this matrix, B from P prime to B, is, if I want to write this in general now, this is dimension 2, but if you do the same thing, you can do it for dimension 3, dimension 4, dimension n. And in that case, this is going to be the matrix you get from writing the second basis, or the coordinate vectors of the second basis with respect to the coordinate vectors of the vectors in your second basis using the first basis. So that is U1 prime with respect to B, U2 prime with respect to B, and UN prime with respect to. That is the structure of that transition matrix, okay? And remember all the time that this is the relationship between them. So here, if the notation is a little confusing, you have to think about B, P prime, this P prime to B. And this here, U1 prime, is coming from here. B is coming from here, okay? In this equation, we have three things. We have the coordinate vector here, we have the coordinate vector here, and we have the transition matrix. So basically, if you know the transition matrix, that will help you to move between bases. So you can think about this. It is like this is a certain currency, and this is certain currency, and this matrix is like the exchange rate. Okay? So you use this exchange rate to help you exchange money from this currency to this currency. Okay? So let's take an example and see how to do the computations here. Let me keep this for a little bit and raise this side. Maybe this here, I keep it up here in front of us. All right, so here is an example. Let me take this example here. U1, my vector space V is R2. And my first basis B is 2, 2. And here, 4, -1. My second basis here is 1, 3, and here -1, -1. Okay? Find, number 1, find the transition matrix E prime to B. Well, we know the transition matrix has columns U1 prime with respect to B, U2 prime with respect to B. The coordinate vectors, so here let me label those as U1, U2, here U1 prime, U2 prime. So what does that mean? It means we have to find U1 prime with respect to B. We have to find this coordinate vector. This coordinate vector, how do we get that? We write this as a linear combination of those. So let me write 1, 3 as a linear combination of those two. So C1 into 2, 2 plus C2 into 4, negative 1. So what do we get here? We get a system of two equations, okay? What are they? They are 1 equals 2C1 plus 4C2, and 3 equals 2C1 minus C2. All right, now, we need to solve this, but I'll come to that later. So let's now think about what is U2 prime with respect to B. Again, we take U2 prime, which is negative 1, negative 1, and we write this as a linear combination of those two. So it is going to be C3 multiplied by 2, 2 plus C4 multiplied by 4, negative 1. Again here, what do you get? You get a system of two equations. So here, you are going to get negative 1 equals 2C3 plus 4C4. And here, 2C3, negative 1 equals 2C3 minus C4. So here we have a linear system of two equations, and we know here from chapter 1 how to solve that. We write the augmented matrix, echelon form, reduced echelon form. So instead of doing each one individually here, why don't we do both of them in one shot? What does that mean? So if I come to this, what is the augmented matrix? The augmented matrix here is 2, 4, 2, negative 1, and here is 1, 3. Now, what is the augmented matrix for this? It is the same thing, 2, 4, 2, negative 1, and here I'm going to put it negative 1, negative 1. So this with this comes for this system, and this with this comes for this system. So here, instead of doing echelon form for two different systems, we do it here in one shot, okay? Now, before I do that, let's think about what we got now. If you look at this, 2, 2, 4, negative 1, what is that? 2, 2, 4, negative 1. So here, this is basis B. And if you look at 1, 3, negative 1, negative 1, this is basis B prime. So basically here, after this example, you can jump right away from here to start with this. You don't need to write this. You can see here a shortcut. You put two matrices. The first one is coming from this basis. The second one is coming from this basis. And now you do elementary row operations to get reduced echelon form. Now we know this is a basis. So those are linearly independent. So this matrix here, it is when you do reduced row echelon form, this is going to be 1, 0, 0, 1. And what you get here, you are going to get the matrix that you are looking for, because that will give you C1, C2, C3, C4. So that is going to be B prime to B. Let me write it, and then I'll do one more step. So this is going to be 13 over 10, and negative 1/2, and here negative 2 over 5, and here 0. I'll leave it for you to double check that. So double check this. Okay, so this here is the matrix that we are looking for. Okay, so what is the answer now? The answer is here. I can write it as 1 over 10. And here 13, here negative 5, and here negative 4, and here 0. This is the transition matrix that we are looking for. Again, let me repeat myself here. You can start right away from here by taking the basis B, the basis B prime, get reduced row echelon form. That will be your answer. That will be your transition matrix. Okay? So that is a shortcut. All right. Now, if we do the following, by the way, this is coming from the basis, this is coming from the basis. This matrix is invertible, this matrix is invertible. This matrix is the identity, this matrix is invertible. So the matrix you get here is always invertible, okay? Which means if you have U with respect to B equals P, here B prime to B, and here U with respect to B prime, and you want to write it the other way around, you can say here B prime to B inverse U B, and that is U with respect to B prime. And this, actually, it is the same if you reverse what we did. So this is, in fact, B to B prime. So always you can do this gymnastics here and evaluate or compute what you want to compute. So whether you do it like this, or you do it like this, both are correct here. Now, in this equation, you have three things. You have the coordinate vector here, you have the transition matrix, and you have the coordinate vector here. So if you know the transition matrix and you know this coordinate vector, you can find this coordinate vector. And similarly here, the other way around. Okay? So if I go back to my example here and ask you question number 2. So here, question number 2. Find the coordinate vector of W with respect to B prime, where W here is, okay, I'm just going to take any vector here, 1 and 3. What does that mean? It means you write 1, 3 as a linear combination of 1, 3. 1, 3, that is 1, 3. So let me make it more interesting. Let me make it 1 and negative 2. So that is 1 and negative 2. Now it's more interesting. Okay, so 1, negative 2, write it as C1, 1, 3, plus C2, into negative 1, negative 1. This is U1 prime, this is U2 prime. Again, here you have a linear system that is 1 equals C1 minus C2, and this is negative 2 equals 3C1 minus C2. So solve it in any way you want. That is very simple. So if you add those, you get negative 1 equals 4C1. So C1 is negative 1 over 4. No, this is 3. This minus this, so we get this minus this, we get 3. This minus this, we get negative 2C1, and this will cancel out. So it means C1 here is negative 3 over 2. And if this is C1, it means 1 plus 3 over 2 is negative C2. So C2 is negative 5 over 2. Double check, please. Am I correct? Okay. All right. So here, the coordinate vector, this one is, hence, or therefore, W with respect to P prime is negative 3 over 2 and negative 5 over 2. Okay? So this is question number 2. Question number 3. Find, this is number 3. Find W with respect to B. The coordinate vector of W with respect to B. Well, here you have two options. You have one option in which you can do it as we did here, and you solve. Or the second option is you do it from this formula here. So here you can say W, you can say W with respect to B is going to be the transition matrix B prime to B multiplied by W with respect to B prime. This we know it, and this we know it. So all you need is just to substitute, correct? So here, 1 over 10, 13, negative 5, negative 4, 0, multiplied by W with respect to P prime. We found it here. It is negative 3 over 2. And here, negative 5 over 2. And when you multiply, what do you get here? You get 13 times negative 3, negative 39, negative 39 plus 25, negative 39 plus 25 over 2. That is so here we have 9, 14, 14 over 2, 7, so that is 7 over 10. All right. And the next one here, you get 12 over 2, 6 over 10, that is a 3 over 5. I think there is a negative sign here. That is negative, that is positive, so there is a negative sign. All right, and that one is positive. 12 over 2 is 6, 6 over 10 is 3 over 5, yes. All right, so this is the coordinate vector of W with respect to B if we find it in this way using this formula. If you find it in this way, I'll leave it for you to do it. You should get the same answer. If you don't get the same answer, then there is a mistake somewhere. Okay, so basically that is the idea of change of bases and how to relate the coordinate vectors using the transition matrix. Let me give you one more example about this and we will be done with it. Okay. All right, so let's do one more example. Let me take my vector space B to be P1. Polynomials of degree at most 1. I'm going to take my first basis to be 6 plus 3x and 10 plus 2x. And my second basis to be 2 and 3 plus 2x. Of course, you can double check here. When I say this is a basis, well, you can take my word for it, but also you can double check that. Okay? Look, you cannot get this vector from this vector. So those are linearly independent. And you know here the dimension is 2. So basically it is, this set is linearly independent and you have 2 vectors dimension 2. So this must span this vector space. So yes, this is a basis, and yes, this one is also a basis. Okay? So here we are giving you that for granted, but also you can double check because sometimes you may find a mistake here. Okay, so here you have two bases, and the question here says find the transition matrix B prime to B. Okay, or again, we may ask you the transition matrix B to B prime. So in that case, you have to reverse the process. Or you find this, and then you take the inverse. Either way, it is fine. Okay, what I like to do, I just like to stick with this, and if I need to reverse it, I just take the inverse. All right. Well, we know what is this. What is this? It is, let me label those. This is B1, this is B2, this is B1 prime, this is B2 prime. So how do we get this one? We get it as we have here. We write P1 prime as a linear combination of those. Which means 2 equals C1 into 6 plus 3x plus C2 into 10 plus 2x. And again, we take P2 prime equals C3 P1 plus C4 P2. And from here, you have 3 plus 2x equals C3 multiplied by 6 plus 3x. And here, C4 multiplied by 10 plus 2x. Now, from those two, we get a system. I mean, from this equation, we get a system. And from this equation, we get a system. Those two systems, they do the following. You get. So from here, what do you get? You get 6C1 and here 10C2, correct? So you have 6, you have 10, you have 2, and from the second equation, you have 3, you have 2, and here you have 0. Now from this, what do you have? Again, you have 6, 10, 3, 2, as here, and here you have 3, 2. Now, this you can think about it as what you have in your first basis, 6, 3. Look, this is coming from here, and this is coming from here. Now, this one and this one, they are coming from here and here. So now do the reduced row echelon form. You get reduced row echelon form. The reduced row echelon form is 1, 0, 0, 1, and here you get negative 2 over 9, 7 over 9, 1 over 3, negative 1 over 6. Hence, the answer to our question is, I can take 1 over 18 out, and in this case it will be, what? It will be negative 4, and here it will be 14, and here it will be 6, and here it will be negative 3. Am I correct? This is our transition matrix, and again, we can use it to move between the two bases, or the coordinate representation of the two bases. All right, so basically that's the idea about change of bases and the coordinate vectors and the transition matrix. So I'll stop here, and next time we move on to a new topic. All right, thank you very much, guys, and see you later.